Hello. I was going to say chat, but I'm not streaming. So, hello YouTube. How are you doing today, you the viewer? I want you to go down in the comments and tell me about your day or something you think about. Or just write something and I will respond with a heart or a comment. How does that sound? A deal? Alright. It's time for part 4 maybe? Yeah, we had we had part 3.5 I think, and then 3.8 or 7 on the Aimbot part, which got us a lot of cool functions. I think this was a week ago. We made the calculate angles, aim, all of the good stuff to make an aimbot. So if you have made it this far, good for you. You are the 1% that will rule humanity, or I don't know. You're a good person in my view. So it's time to make the ESP wallhack, not shams, but the see-through walls feature. And how we do this is by finding the viewmatrix, which is a 4x4 float matrix that has the camera position. It has other numbers which we use to calculate the depth and where it should be on our screen. So 2D coordinates, 3D coordinates to 2D coordinates. We found something that looked like viewmatrices on the second part when we jumped into Assault Cube with Sheet Onion, but we didn't know for sure which one it was. This part will show you how to confirm your assumption. So we had, let me open the notepad. That's just a default. And there we go. So we had made a guess at this address. So this is without the base or the module base, but we made an assumption that this address minus 6c is the start of the matrices. And today we will check these ones. We will check if it gives us 2D coordinates that are according to where the players are in game. Enough of me rambling. Let's make some functions. So go to our functions document or script, and here we're going to make a new method which is called viewmatrix. So not below the constructor, but above the constructor we will create a viewmatrix method. So this data type is just 16 floats together. We will call this ReadMatrix, and in this we will create the variable viewmatrix, which equals a new viewmatrix. So that class we made earlier. We will also declare a variable mtx which has the values or the floats that we get from mem.readMatrix. So what our memory class and .readMatrix does is it returns an array of 16 floats, which is a 4x4 matrix. This class could easily be just a float array, but this looks nice, and we can access the different floats by the m and then number. So it's hard to explain because I'm stupid, but don't worry about it. I know some people wrote comments saying that I'm an expert, which is very flattering because I'm not near an expert. This is just a hobby, and I leave a lot of errors in my videos. But since we want to return a viewmatrix data type instead of this float array, we will have to manually change them. So m11 equals to the first value, which is the 0 starting. And now Visual Studio makes it easy for us with the autocorrect thing. I love this new feature in Visual Studio. I just have to press tab. Look. Amazing. And we're done with the ReadMatrix method. So we just translate a float array to our class object and set them to the correct fields. Let me just skim through this, making sure there are no errors, and we should be fine. So now we have read the view matrix, hopefully. Now it's time to translate this to 2D coordinates, or use a 3D object and use the view matrix to calculate 2D coordinates. And for that we will create a method which is called, and it will be a point because .NET has the point data type. It's like a vector2, but when you draw stuff it usually uses points and so on. So it will be a point WorldToScreen method. I'm sure you have heard this on the World Wide Web, but this WorldToScreen method will take in the view matrix that we read here, mtx, and it will take in a 3D position, so position. It will take in the width. Am I slow? I am. The width and the height. So these are screen dimensions. So the width of the game and the height of the game. We can just we're going to make our form stand on top of the underlying application and set the same dimensions, so we can just use this and say the form height, or the form width and form height. So don't worry about this, it will calculate itself. Here we'll have a variable which will be the point that will return. So here I will declare some variables, but this is the translation. So the screen W, which is the depth, I think. It is something, but if this is below a certain point, it means the guy is behind you or behind your screen. So you can use this to check if they're behind you or not, and thereby not draw them. But it will be the M14 times the X position plus the M24 times, it should be a parenthesis here. So I think, yeah, the parentheses are important. Make sure to use them, otherwise you will probably mess up the calculations. But it will be plus the M24 times the position Y, and lastly, or not lastly, but the M34 times position Z plus the M44. So these are just different floats. Let me maximize this. I know someone complained. They said, can you please record in 1440p, because we can't see the code clearly. And the funny thing is, I do record in 1440p, but I render in 1080p. So checkmate. No, but rendering something like this in 1440p will take hours. So no, I don't think I will render the stuff in higher quality. I think full HD is enough. So here was the screen W that I was talking about earlier. So if it's above, this is just a number, a small number. So if it is above this, it means the character is behind us. And no, wait, so this is if they were behind us. I messed up the operator, but if it is higher than this, it means they are in front of us. So if they're in front of us, we will further or calculate further stuff. If they're behind us, what's the reason for, you know, calculating the 2D dimensions? We will not render them, or we will not show them. So the screen X will be 11 times position X plus M21 times position Y, M30 times position Z, and lastly plus, no, not 44 but 41. I think Assault Cube is open source, so you can take a look at their own viewmatrix class and thereby understand this better. So this explanation is not good enough, I know. M12 times position X, and then M22 times position Y, and that should not be minus, otherwise the autocorrect got it right. So M32 times our Z position and plus 42. So the final step to convert this to our 2D coordinates on screen will be to divide it, or divide our screen with, wait, what? No, it's not the final step. There's this step before, so we're getting the cam X and cam Y by dividing our width and height, so by 2. After this we get, or finally get, our X and Y. So we add a cam X plus parenthesis cam X times screen X divided by screen W, and we do the same, but instead of plus we do minus on cam Y, and it changed out on cam Y and screen Y, and also divided by screen W. Now, because it is floats, we had to convert them to integers. Lastly, return 2D. Since we need every path to return something, if they're behind us, we will just return a new point that has the coordinates -99 and -99, so off screen, and we can check if they're on screen and not draw them if they're not on screen. It says that. Now I'm thinking if I need another function or method, and I don't think I need any more methods. It would be drawing the stuff on the screen. So we have our beautiful default form here, and this is going to be our overlay. So we have done nothing so far to the form itself, graphic wise, and what this course gives you is this method of making the form invisible and setting the same coordinates so it is over the underlying application, thereby making it easy for us to just draw on the form itself where the ESP should be, and so on. I do have a external library for this, so I use the the ezoverlay, and I will link it in the description, but you go to dependencies, add project reference, no items found, annoying, but you will get this ezoverlay module, or .dll, this one, and after you have done that, we go back to our form.cs. I think it is open source as well, it's on GitHub, so all it does is import DLLs, sets the background to transparent, removes this stuff, it removes the closing and so on. Also creates a thread which each 10 milliseconds check where our process is, and sets the overlay to that position and creates it topmost, so it's on top of the assault cube. But I will open assault cube as well to just check things are working. One second. Okay, but we have added ezoverlay, and when you have done that, we're ready to use it. So using ezoverlay, and here we need to reference the class, so equals new easy. We also need to do some initializing, so here in the load method, since if it isn't null or if it isn't crashed yet, which I think it will, we can just set our form to invisible with the ezoverlay, and do stuff to, and the window name, so not the name we use, let me check out, it's not the same as the process name and window name, so here it is, assault cube, I misspelled that, assault cube, and it is still this form we will do stuff to. I think you usually want to create another form and have one form for the overlay, so you can have a menu which isn't run by ezoverlay, and then you have a separate form which does all of this stuff. If you run this now with having assault cube on, it should be invisible and not be seen. My voice is breaking down. So it is invisible now. If you were quick to notice, you saw a window here which had a transparent background and the border was quickly seen, but it disappeared after that. So in reality, it is on top of the assault cube window and on top of the Visual Studio editor. But we want to draw something, so we want to draw, let's try dots on top of the enemies. So since ezoverlay is on top of the application, or the form is on top, we can just draw this directly on the form. We can draw, and how you trigger that function is by refreshing the form or anything. So we need the paint function, paint method. Did I miss it? Or is it even here? Okay, size changed. Why is it not by ABCs? Because I didn't. Okay, so here's the paint method. Double click on it and you will get this form 1 underscore paint. In this method, we will reference the graphics. We will create a pen, a red, new pen. Not back color, but color dot red, After that, we will specify the width of the pen, and let's just pick 3. After that, we will have a green pen, which you guessed it has the color green. Also 3 in size. And after that, we will loop, not for color, but for each, and in entities dot to list. So this is important to add the to list, because otherwise this list will change and that will lead to a crash. We will use the WorldToScreen function. So WorldToScreen and then defeat, which equals to m.WorldToScreen. We use the m.read ReadMatrix. Wait, what? Oh yeah. Okay, never mind. It is our methods class. I was confusing it with our memory class. That will not work. You will get a float array. We will use the 3D coordinates of the feet. Lastly, we will use this dot width and this dot height, because the form is the size of the application. Now we have the feet. We will do the same for the head or the camera. So now we have the 2D coordinates of the feet and the 2D coordinates of the head. We check if our feet, so if it is on screen, is greater than 0, which means it's not outside the screen bounds. After that, let me full size it again. My headphones died, so I have this cable in the way. My charger is really bad. But we will draw a line to... Actually not, we will check if it is a teammate or not. So if local player.t equals the entity we're trying to draw. If it is, we will draw a line with the color okay, so someone was screaming, but we will need a point, and this point will be not at the middle. Yes. Well, we do have we have a point, so let's just use the... Oh, it's 2 points. Never mind. I'm just I'm trolling, but we will draw the line from the middle of the screen. So the width divided by 2, and so we need parentheses for that, for a new point. After that, we need a point to draw. So we have 2 points. We have one at the bottom of the screen, and we have one to our... That should be the feet. There we go. My bad. We need to use the e.graphics, so paint event arguments. So we check if it's a teammate. If it is a teammate, we draw a line to them. We can also draw a red line to our enemies. So draw line red, height and feet width divided by 2. There we go. So let's add some bots and try this out. So team deathmatch best 2v2 because I have the maximum entities of 4. Pick the map deuce. I have some enemies jumping around. Let's they are wrecking me, so let's make them idle. After that, start. Now a tip is to wait until it gets to start on its own, and it doesn't draw anything. That's because we haven't made the form to refresh, so it doesn't repaint. We have just specified what it will do when it repaints. So that's my bad. Let's go back to our main method. In the main method, we will just add form1 f equals this, and then refresh. There we go. So start again. And we haven't tested if it is the correct view matrix yet. So it does draw some lines, but as you can see, it's pretty wrong. It's not correct, so to speak. This means either our WorldToScreen function is wrong or the viewmatrix is wrong. So the good thing is we already know the viewmatrix or the WorldToScreen function should be correct in this one. So if we go back to our viewmatrix address, we had 2 in our notepad. And we also had, we know where it started, so at 6C. Let's, we can gamble and say minus 6C to start, and then go, just skip 16 floats and try the next one. So this is the start. And we try and run it again. It's wrong again. It still draws something, but it's completely nowhere near the actual players, which means it's wrong. What we do next is just add 16 floats, so 4 can do, make it hex times 16, and try the next one. And would you look at that, it draws to the position of the players. So this wasn't scripted. This is one way to do it. It might not be aligned, so you will probably have to try not just jumping 16 floats. It might be in between, so maybe it might be one float wrong and it will give the wrong calculations. So try the matrices that you think might give the correct 2D values. That's just how it is. We have our ESP now. It draws to the locations of the players. You could use this in game, but we want to draw on boxes on top of the players, and not just these lines. So we will need to create a rectangle which begins at the head and stops at the bottom. To do that, we go back to our functions again. Yeah, there we go. And it will be the last method. Maybe not the last. You can add on whatever you want to this functions list, but it will return a rectangle. So calculate rect. It will take in point feet and point head. So you will need a head position and feet position, and why it's not a fixed value is because if they crouch, it will not react. So we will need some live values. We will have a rectangle, and the properties will be the head x minus the head y minus, never mind, the feet. Because these are screen coordinates, it means the feet is a higher value than the head, because it's 0, 0 at the top and it goes down to your screen bound. So for example, my screen is 1440p, it starts 0, 0 and it goes down 1440 and 2500 pixel to the width. But we have the feet minus the head divided by 4. So our rectangle, it's going to be in the middle of the character, so we need to offset it to kind of match where he is and his width and so on. So we subtract a fourth from the middle to make the rectangle fit over the player. That's it. We have our y, which would be our head y. Just our head y. We would have a width, which will be the height divided by 2. So feet dot y minus head dot y divided by 2. We will have the height, which will be the feet minus height. That's how we have always calculated the height. After that, we just return our rectangle, and now in our paint method, we just use the draw rectangle. So g dot draw rectangle, and it's green because it's our teammate. And now use m dot calculate rectangle. Just specify the feet and the head position. Then copy paste, change the color to red when it's the enemies, and I think we're done. So let's try that again. And we have some really ugly boxes What happened here? Oh, Lord. Okay, something's really wrong. Let me quickly check what it could be. So, calculate rectangle. My headphones just died again when I had the charger in. How is that possible? Well, I don't mind it. As long as the microphone doesn't go off, I'll be good. So we have the x minus x divided by 4. Oh wait, yeah, I think it's auto-corrected on me. Or I'm just stupid. So the height, it's minus. I don't know how that, or how I missed that. So now we have much better looking boxes, which covers the players more or less. So let's set them to non-idle. Let them jump around, and I instantly died. And we can see them through the walls. We have our aimbot on mouse 5. Truly amazing. Truly amazing stuff you can do with programming and creative thinking. If you did complete this whole course, good for you. I'm proud of you. Maybe write a comment like, I did it, and I will respond to it. Not just a heart. I might even pin it if I'm feeling good. Thank you guys for joining me on this journey. I don't really know what I will do next. Maybe something I enjoy, like a fun little project, but whatever. Something simple and easy and not that time consuming. So you can suggest something, and you can suggest in the Discord or in the YouTube comments. I think I will read it both. Thank you for watching. Have a good one. Subscribe, like. See you guys.